Learn like a pro.
All right, hello everyone and welcome. Today, we're putting on our detective hats because we are about to crack open a brand new case file, a fascinating chemical mystery. We're going to uncover a secret world of hidden energy swaps that are happening all around us all the time. So, let's start our investigation. Okay, first up, a little riddle to get our brains working. Take a look at these two things, a rusty old car and a battery for your TV remote. I mean, they seem totally different, don't they? But believe it or not, they share a really important secret. What do you think it is?
If you guess that it has something to do with energy, you are totally on the right track. Both rust and batteries are the result of a secret transaction, this hidden swap of energy between the tiniest of particles. It happens everywhere, and today, we're going to learn how to spot it.
So, let's get into the details of our case. First things first, we need to understand what's actually happening here. This invisible energy swap. What's being traded, and why?
The official science name for this energy trade is a redox reaction. Now I know, that sounds kind of complicated, but here's all it really means. In certain chemical reactions, tiny little bits of energy, called electrons, literally jump from one substance to another. You know, think of it like one person tossing a baseball to someone else. That baseball is the electron, and the throw, that's the reaction.
Every good detective story has its key players, right? Well, in our chemical case, we're not looking for suspects. We're looking for partners. Let's meet the two characters that are involved in every single one of these energy trades.
In any redox reaction, you're always going to find two main characters. First, there's the electron giver. This one is super generous. It just gives its little bits of energy away. Then you have the electron taker. This one is a little more greedy. It's ready and waiting to snatch up that energy for itself.
Okay, so let's learn their official scientific names. Our electron taker, the greedy one, is called the oxidizing agent, and our generous electron giver is called the reducing agent. But here's where it gets really interesting, a little bit of a twist. The names actually describe what these guys do to their partners, and the opposite thing happens to them. Let's take a closer look at that.
So check this out. This slide shows the whole swap in action. See how those arrows cross? The reducing agent, our giver, ends up getting oxidized. At the exact same time, the oxidizing agent, our taker, ends up getting reduced. So just remember this. Their name describes the effect they have on their partner, not on themselves. It's a little weird, I know, but you'll get it.
So how do we, as detectives, actually see this invisible trade? I mean, we can't see electrons moving. Well, lucky for us, these reactions often leave behind some very obvious evidence. The biggest clue is a color change. Seriously, think of it like a fingerprint left at the scene of the crime. When the liquid in your test tube changes color, it's basically shouting, hey, an energy trade just happened right here. It's our #1 piece of visible proof.
And this? Well, this is our detective's cheat sheet. It's the absolute key to cracking our cases. It links a specific color change to a specific agent. For example, if you see a really vibrant purple solution suddenly turn completely colorless, bam! That is a dead giveaway that a certain oxidizing agent was at work.
So how do we use this? Well, we use the vice versa principle. It's kind of like setting a trap. To find out if you have a generous giver in your mystery solution, you add a known taker to act as bait. If a reaction happens, if you see that color change, you've caught one.
So our investigative plan is simple. Just 3 steps. 1, add your bait. That's your test agent. 2, watch very carefully for that telltale color change. And 3, use your cheat sheet to identify the hidden partner that was in your solution. It's really that easy.
All right, detectives, you've got the theory down. Now it's time to apply our skills to a real case file. Let's look at a classic reaction and see if we can identify our giver and our taker.
So here's the scene. We've got a solid piece of zinc metal, and we're adding it to hydrochloric acid. The equation you see here shows us what's about to happen. An invisible transfer of electrons is about to take place. The big question is, who gives and who takes?
And case cracked. The notes on this slide show us exactly what happened. Zinc acted as our giver, the reducing agent. It gave its electrons away and was oxidized. The hydrochloric acid was our taker, the oxidizing agent. It accepted those electrons and was reduced. Mystery solved.
Now that we've solved a case in the lab, let's see where else these reactions show up. You'll be amazed at how many everyday things are actually just redox reactions in disguise.
Remember our first riddle? Rust is simply iron, our electron giver, handing over its energy to oxygen in the air, which is the taker. That familiar brown color is the evidence. Batteries are just really clever containers that control a redox reaction to create a flow of electricity. And when you slice an apple and it turns brown, yep, that's oxidation too. It's the apple's chemicals giving electrons away to the oxygen.
Okay, you've been great detectives so far. Now it's time for a quick pop quiz to see what you've learned. Let's do a little quick-fire round. Ready?
First up, in one of these secret energy trades, what are the tiny particles being swapped? I'll give you a second. If you said electrons, you are correct.
Question 2. Let's test your memory on the official names. Which one is our generous electron giver? Was it the oxidizing or the reducing agent? It's the reducing agent. Great job.
And for our final question, what is the biggest, most obvious piece of evidence, that fingerprint at the scene that tells us a redox reaction is taking place? A color change. You got it.
And that's it. You've officially passed your detective training. You know what a redox reaction is, you can identify the key players, and most importantly, you know how to spot the clues.
So I'll leave you with this final thought. Now that your eyes are open to this world of invisible energy trades, what other everyday puzzles will you uncover? The world is full of chemical mysteries just waiting to be solved. Happy investigating.